So hello students, from today we are going to start a lecture on 12th HSC Maharashtra Board Physics, and the first chapter that we have in our book is Rotational Dynamics. Okay, so we'll first see what is the meaning of this rotational dynamics, and then we'll move to the further topics of this chapter. So the first thing that is there is what is rotational dynamics. Okay, so it is made up of two words. As you can see, the first one is rotation and the second one is dynamics. Okay, so what is rotation? Basically, rotation means revolving around its own axis. Suppose there is a body and it is revolving around its own axis. As you can see here, it is revolving around its own axis, so that is called rotation. Okay, whereas if a body is revolving around some other axis, that is called revolution. Okay, now it is rotation and the other one is revolution, so we are going to deal with rotation only. What is dynamics? Basically, so in physics you will always have two parts, that is static and the second one is dynamics. So static means you will be studying about something which is at rest, and whereas dynamic means you will be studying about the things which are in motion. So here we are going to see the body which is in motion, and we are going to see its rotation. Okay, so what all physics works on that body, that we are going to see. Okay, so let's start with the first topic that we have in this chapter, that is your circular motion. Okay, so as you can see here, there is a body, and let's say the first position of that body was at A. Okay, let me take this laser. Yeah, so the first point of that body was A, and now it has moved to B. This body, as you can see, it is tracing a circular path. Okay, so this is moving in a circular path, so that's why the name is circular motion. Okay, now initially the body was at A, and after a certain amount of time, what we have seen is the body has moved to B. Okay, let's say that body has moved by an angle theta. Okay, so this body has moved by an angle theta, and O is the center of the circle. Now OA is your radius vector, and same is your OB. Now let's say from A to B the body is moving. Okay, so from here to here. Now while moving, what it does is it covers a linear displacement. Okay, means there is a linear displacement of this body from A to B. Okay, and let's say that linear displacement is S, because displacement is always denoted with the small letter S. Okay, now this is theta. What is theta? Basically, theta is the angle by which this radius vector has moved from OA to OB, so that is your theta. Now you might have seen in your 11th standard that there was a formula of arc length. So by arc length, if theta is your angle and small s is your length of the arc and small r is your radius of that circle, then this was the formula, that is theta is equal to s upon r. Okay, so by the same formula you have theta is equal to s upon r, but here the meaning of theta is what? The meaning of theta here is your angular displacement. Okay, how it is your angular displacement? So it is your angular displacement here because your radius vector that was initially OA has moved to OB, means now it is OB by an angle theta. Okay, so sorry, yeah, so it has moved to an angle which is theta to OB. Okay, so this was your radius vector initially, and now also it's your radius vector only. Okay, is it clear? So this was about your what called circular motion. So here your small s is your linear displacement, whereas your small r is the radius of the circle. Okay, so small r is the radius of your circle. So this was about the circular motion. Now the one thing which I missed here is what will be the unit of your theta. Okay, first of all, the unit of this, that is the unit of your s is nothing but meter, because it is displacement, so the unit of displacement is meter. SI unit of displacement is meter. Now here it is radius, so for radius also it is meter. Okay, the SI unit will be meter, so both will be having meter, and this is also having meter. Okay, but the angle is theta, so theta can have two units, either it can be a degree or it can be radian, but here we take what, we take here radian. So the SI unit of your theta is, the SI unit is, so its SI unit you can write somewhere, that is SI unit is what, SI unit is nothing but your radian, so it is equal to radian. Okay, so this is your SI unit, and that is equal to radian. Okay, so this you can write somewhere, that the SI unit of your angular displacement is radian. Okay, so this was all about your circular motion. Now in the next video we will see more about this chapter. Till the time, take care, bye.